Next, central air data computer. Aircraft that operate at a high speed and high altitude can have significant error in the pitot static system instrument if it uses a simple system. An air data computer ADC is used to operate airspeed indicator, altimeter, VSI, any other system that require this data. The air data computer is placed in the system between the sensor port and the instrument to automatically apply correction in order to increase accuracy. The air data computer has three input: pitot pressure from the pitot tube, static pressure from the static port, total air temperature from a special TAT probe. So TAT measurement is needed to correct the instrument indication for friction heating of the air at a high speed. TAT probe also permit the calculation of SAT, which is used to apply correction for non-standard temperature of any flight altitude. The outputs of air data computer is supplied to a number of aircraft system. This is central air data computer. High-speed jet airplanes require Mach meter. This could be a separate instrument or included with the airspeed indicator. Aircraft with an air data computer usually have a digital display on the instrument panel which gives calculated true airspeed, total air temperature or static air temperature. TAT includes heating effect of the friction at high speed, whereas that is just ambient outside air temperature. Altitude indicator system. Altimeter principles. Although there are many different types of altimeter in service, all pneumatic altimeter operate on the principle of aneroid capsule, which expand or contract with the changes in atmospheric pressure. As the aircraft altitude increases, the static source senses the decrease in atmospheric pressure and causes the aneroid to expand. This movement of the aneroid actuates mechanical linkage which drive the pointer to the proper altitude scale reading on the indicator. A bimetallic yoke surrounding the aneroid compensates for inaccuracy caused by variation in temperature. The most common source of altimeter error is caused by the scale not correctly oriented to the standard pressure condition. Since the atmospheric pressure continually changes in level flight, the altimeter scale must be calibrated to the local barometric setting before the altimeter will indicate the correct altitude of the aircraft above sea level. When the barometric correction knob on the face of the instrument is turned, the pointer and aneroid mechanism move to the new altimeter setting. So two types of error which is common are hysteresis error, static port alignment error. This is the diagram of altimeter indication and setting. Next, radbar encoding altimeter system. The Goldsman electro-pneumatic encoding altimeter system is designed to provide both barometric and radar altitude information in a single instrument. The barometric section of the altimeter measures and displays static defect corrected pressure altitude, encodes that altitude into a binary code output. This is sent on the board radio beacon transponder for automatic altitude reporting. Synchro outputs of the baro corrected altitude are provided for altitude alerter, flight management system, long range navigation system. An altitude rate signal is provided to drive an vertical speed indicator. The basic mechanism of the barometric section of the radar indicator is servo operated diaphragm displacement followed transducer. By sensing the diaphragm motion through an inductive pickoff, very accurate repeatable altitude measurements are made and presented on the altimeter counter drum pointer display. Altitude digitizer. The optical encoder in the barometric section of the altimeter uses light emitting diode as light sources and photon Darlington transistor as light sensor. An encoding disk with a 9 concentric track of clear and opaque section is positioned between the LED and photosensor. As the disk is rotated by the altimeter aneroid mechanism, the light passing through the clear section of the disk track the altitude changes. For every 100 feet of altitude, a new combination of light pattern reaches the sensor to produce the coded altitude information, which is processed into a binary code output and sent to the transponder. This is the encoding altimeter. Radio altitude readout with the voice terrain advisory. The radio altimeter section of the radar altimeter is connected to a radio altitude digital to analog converter to provide 3-digit 7-segment incandescent digital readout of the absolute altitude or height of the aircraft above the terrain. The radio altitude converter receives analog signal from the radio altimeter and glide slope signal from the ILS navigation receiver. Radio altitude signals are converted to digital form to drive the radio altimeter display in the radar altimeter and also to provide voice terrain advisory output of radio altitude alerter. The altitude alerter is an optional instrument used to alert the pilot of an approach to or departure from a preset flight level by means of a automatic audio and visual signal. The input signal required to operate the altitude alerter consists of two-speed baro-corrected synchro altitude signal from a servoed altimeter, a 26-volt AC 400 Hz reference voltage from the aircraft electrical bus instrumentation transformer. So flight test procedure in actual operation as the aircraft approaches within 1000 feet of the preset flight level, the altitude alert light comes on and an RL tone is momentarily heard through an external tone generator. The light, however, remains on until the aircraft crosses 300 feet of the preset altitude, at which time it extinguishes. So the aircraft deviate from the preset altitude by more than plus or minus 300 feet. The oral tone and alert light will again be activated. The light will then remain on until the aircraft returns to within 300 feet of the preset altitude or until the pilot selects a new altitude setting on the alerter indicator.